Whenever we calculate probabilities based on data that's been collected, it's super important that we pay attention to who the probabilities apply to. So in this case right here, we had a sample of 990 pedestrian deaths related to automobile accidents. And we checked two categorical variables. Was the pedestrian intoxicated? Yes or no. Was the driver intoxicated? Yes or no. And so this is what we call a contingency table summarizing those two right there. And in all the problems that we dealt with based on data that was collected, the probabilities apply to a randomly selected person. Now, you or I are not necessarily a randomly selected person. Okay, so these might not apply to you and I. Now, I think we are all pedestrians often. So we might be a randomly selected person that's legitimate for this right here. Important, randomly selected person. At this conference, 90 people were surveyed. We got this data, and they're hoping that that's a representative sample of the population, so that if a randomly selected person is selected, we can say, hey, what's the probability they owned a Ford? Oh, it's about 40 out of 90, which would be like 44% of people own a Ford, is what this might tell us in general about people. What's important about that probability? It applies to a randomly selected person. Okay, I have a friend who does not drive. They're 30 years old. They've never driven a car. Would they be a good randomly selected person? The answer is no. This wouldn't apply to them. Okay. So randomly selected person is important. Individual people, not randomly selected, can be dangerous in interpreting probabilities. When we're talking about disease testing, it's got to be a randomly selected person we're talking about for these calculations right here. Okay, so here's some data that I collected. This was from about 5 years ago. What I have here are the number of deaths of a passenger in a car. Number of passenger deaths in a car. There were 25,000 5 years ago in the US. Number of deaths of bicycle riders 5 years ago was about 2,000 in the US. 2,000 people died in a bicycle accident. Okay. Whether they hurt by a car or they just had some other accident, who knows? Tsunami. Yes, tsunami waves sometimes make it to the United States. And 5 years ago, there were 5 recorded deaths that were attributed to a tsunami in United States territories. Backcountry skier. 5 years ago, there were 5 documented deaths of people dying in a backcountry skiing accident. Okay, so if we randomly select a person, what's the probability that they died in a car accident? So I'm just going to probability car. Well, pretty much everybody in the US is in a car on a regular basis to do something. So 25,000 people died 5 years ago. There were 330 million people in the United States. We can whip that out on a calculator. Okay. So let's suppose that probability still applies this year. What's the probability I die this year or over the next 365 days in a car accident? It's probably that. It's probably that same number. What's the probability I died 5 years ago when this data was collected? 0. I'm alive. I'm not dead. Right? Okay. Bicycle rider. What's the probability a bike rider randomly selected dies in a car accident? Sorry, not a bike rider. What's the probability a randomly selected person in the United States dies in a bike accident? If it's a randomly selected person out of the whole United States, it is definitely 2,000 out of 330 million. I ride a bicycle daily. If somebody said, what's the probability, if that probability is still true this year, what's the probability Gary dies over the next 365 days in a bike wreck? My probability is probably higher than that. because I ride a bike every single day. Does the average person in the US ride a bicycle every single day? The answer is no, they do not. Okay. All right. Harley, do you ride a bike? Not at all. What's the probability Harley will die in a bike ride? Bike accident. It's less than that because Harley doesn't ride a bike. Right? Okay, so again, randomly selected people, data applies to. Individuals, maybe, maybe not. Anybody here backcountry ski? I don't. What's the probability one of us dies over the next year in a backcountry ski accident? It's less than 5 out of 330 million because we don't backcountry ski. Ain't gonna happen. Okay. All right. What is there a slight chance somebody might invite you out in next winter to go backcountry skiing? Yeah, and you might say yes. Okay, so that increases the probability a tiny bit, but it's still probably less than 5 out of 330 million. If it's a randomly selected human or a person in the US, then the probability is 5 out of 330 million. But again, applying it to an individual is dangerous. And looking back in time to one of us is impossible because we're alive. Right. So my point is probabilities should always be approached with a little caution and thought. Because they apply to randomly selected people, but individually picking out a person, that changes things dramatically. And then I always get asked, well, what's the formula for like you or me? Doesn't exist. Probably doesn't exist. There probably isn't a formula to figure that out. It's just all we can say is it's less than that because you don't ride a bike, or it's more than that because you ride a bike more than most people. Right? That's all we can say. There's just so many things we can't answer. But we can scratch the surface and answer more and more things and get ballpark answers for some things or rule some things out. So it's complicated. It's interesting. Probabilities are wonderful. Almost everything in your life involves some kind of probability here and there. All right. That's my spiel. Thank you for listening.